Are you tired your .NET application failing in unpredictable environment? Stay tuned because today we will discuss how to safeguard your application using Polly and hedging technique in .NET 8. My name is Iman and today I will show you how to implement the hedging scenario using Polly in .NET 8. Let's introduce the hedging strategy. The hedging strategy enables the re-execution of the callback if the previous execution takes too long. This approach gives you the option to either run the original callback again or specify a new callback for subsequent hedged attempts. To make this matter more clear, let me show you the sequence diagram from the document website. I will put the link in the video description. Please read the documentation carefully because not everything can be covered in the video. Let's break down the sequence diagram. We have a caller who initiates a request. This request then passes through a pipeline, which is essentially a chain component that can modify or enhance the request. Here we have call execute async and call execute core that we will discuss in our code about them. When the pipeline receives the request, it's call execute async. In the code section, we will investigate the execute and execute core methods. This is where the hedging strategy comes into play. Here we have wait start and wait ends. The hedging component sets a timer. If the response from the service doesn't arrive within the specified timeout, the hedging component will initiate a callback or alternative execution. In this happy path scenario, the response arrives before the timeout, so the hedging component doesn't need to trigger a fallback. The request is processed normally and the result is returned to caller, as we can see in our sequence diagram. Now, let's dive into an unhappy path where the hedging strategy is triggered. As before, we have a caller initiating a request and it passed through the pipeline. The hedging component set a timer again, but this time the response from the service takes longer than the timer. Since the timeout is exceeded, the hedging component triggers a fallback execution. Here we have invoke request 2. A second request is sent to a fallback service or a different instance of original service. The request is processed quickly. After return the result of second request, our hedging step propagates cancellation token to the first request and it cancels the first request. I wanted to define a simple scenario considering our user wants to get temperature, but our service which provides the temperature is unreliable and sometimes slow. We have criteria for a quality attribute that state a user should not wait more than 2 seconds for its response. So here the user call our service and our service send the request to temperature service, and after that temperature service respond to our service and our service respond to user. Okay, I want to call this method in the hedging pipeline. The temperature controller with one action called get from service may sometimes have slow responses. In this action method, our hedging just re-execute calling service. It's our action generator here. First, we have to create our pipeline. So we use this builder. The generic type of our resilience pipeline builder is determined by the return type of our service. So here we have add hedging and .build. This is a normal builder pattern. We call execute async method that gets a func for input. It's a delegate that is our original service that we want to call. And passing a cancellation token is necessary to cancel the first request after returning response from the second request. Okay, we must pass options to add hedging. Let's look at options properties. We have to instantiate the generic class hedging strategy option, which should be the same as the return type of the method or service that we want to invoke in our hedging scenario. In options, we have a delay, which represents the wait time for hedging execution. Max hedge attempt determines the maximum number of hedging attempts. Action generator delegate determine the action after hedging. Here we just want to re-execute our original method. And the on-hedging event is raised whenever our hedge occurs. Let's look at get current time service. Here we have a random millisecond delay generator. It's a simple method that generates random delay. I use bogus here for generate an integer between min and max. It's like the delay time, and try and catch for catching or operation cancel detection, and like that for more investigation. So we call random millisecond delay generator with between that's generate a delay between 1000 millisecond to 5000 millisecond. Let's run the project and call getFromService. After call our API, we can see something like this in our console. I prefer to show is a screenshot because it is not deterministic response. First line shows the delay which greater than 2 seconds. So we expect our hedging action should call after 2 seconds. In third line, log the zero hedging attempt and call the method again afterward. The next line shows our method call again, but our first request return its response. Here we can find out it is the first request response. And a task was cancelled for the second request. The second scenario is call another method in our hedging action. In the second scenario, we have added a cache server that can respond quickly if the main server response is slow. Here I have set the delay trigger to 1 second to make the behavior more sensible. The difference between this scenario and previous scenario is that if the main service does not respond within a specified time, the second, which is faster, is requested. You can see our method here. I want to show you. This is a method. It returns a delay. This is a method. It generates a delay between 0 and just 100 milliseconds. Let's call the second API. As it is clear in the log, the first request is sent with a delay of 4.5 seconds. After 1 second passes, hedging pipeline trying to call the second service. The delay of second service is only 32 milliseconds. In this case, we expect that the first request is to cancel. So here we can see a task was canceled for the first request. Okay, that's it. We have seen two scenarios of using hedging in Polly.NET. Please share your idea about this video and your use cases in the comment section. See you soon. Bye bye.